let's do some graphing. This won't be very long, this homework. So before I type this into Desmos, what do I know already? I already know the power term. I'm going to do it right here. The power term is negative x cubed. I know it doesn't ask for it, but the degree is 3, and what do we call this? Is a cubic. So before even that, I understand the power term, the degree, I know the name of it. What does that mean? So do I know how to say the word right in math? And I know the right end is going down, so that's negative infinity. Left means as x approaches negative infinity, and the left end is going up. So I know this before I type it into Desmos. Then I'm going to go to Desmos. You should press pause or type it in Desmos with me. Here it is. That's negative x cubed plus 4x squared. Take away 7. And I'm looking for intercepts and turning points. I'm going to put those on my graph. And I'm just going to round. So, there's my red pen. So I'm going to put what I see there. So I'm going to use negative 1 as an x-intercept, and 2, and 3. This turning point is going to be in between 1 and 2, 1, 2, and 3. So I'm going to put that down like 2.5 and 2.5. And 0, negative 7, that's simple enough. Okay. So just the one that may be a little tricky. So this is what it looks like. I'm going to connect it smooth and curvy. There it is. So I'm not worried about this. We have a minimum here at 0 and negative 7. I'm going to call that max. So I know I said to round to a whole number, but we're going to use decimal, so it will. If I use 2 or 3, it's an intercept, so it makes more sense. And then this graph decreases, so from negative infinity to 0, it's decreasing, and then from 0 to 2.5, it's increasing, and then from 2.5 to infinity, it decreases. That's it. All right, try number 6. See if you can do it. So if I ask for the power term, do you know what to write down? Do you know what the degree is? Do you know, this is called a quartic, but we won't worry about that. Do you know the end behavior? We'll do that over here. So we know the power term is positive and even, so that means the right end goes up. Again, we always write the beginning of these statements never change. So the right end goes up, the left end goes up. Then I'm going to go to Desmos, and I'm going to type it in. So x to the 4th minus 3x squared. Oops, where are we at? So x to the 4th minus 3x squared minus x plus 2. So these are the points I'm going to put on my graph. And I'm just going to estimate where some of them are. Some will be easier estimates than other. So that first minimum is like negative 1 and 1. That's where I'm going to put it on my graph, negative 1 and 1. And then I have a y-intercept at 2, but I have a maximum that's right beside it. Here's the thing. I'm just going to say that 0, 2, it's basically the y-intercept. If you round it, I'm just going to use 0, 2 as my maximum. Then I have intercept at close to 1. I have another intercept at like 2. So we're going to again say 1.5, negative 1.5, and then I'm going to come back here. So we know both ends go up. So there's the picture of what it looks like. So we have a minimum here. We're going to call that negative 1, 1. We have another minimum here. This one we're going to call 2.5, negative 2.5. We have one maximum. I said we're going to call that 0, 2. And then the graph first decreases, so negative infinity up to negative 1. It increases from negative 1 to 0. From 0 to 2.5, it decreases. And then from 2.5 on, it increases. All right, last part is super simple. Zoom out just a little. So it says, A, tell me if the degree is even or odd. So if they go in opposite directions, we know the degree is odd. Is it positive or negative? So if the right end only tells me that. So the right end is down, it's negative. Here, again, both ends are going in the same direction, so it's even. And the right end tells me positive or negative. So if the right end is down, it means it's negative. If the right end was up, it would be positive. And we're done. 6 minutes. Are you kidding me? Mr. GMath.